Right, in this video we're going to be having a look at the IV characteristics of a filament lamp. So just to really quickly point out that a filament lamp is basically a lamp like this, and it's just got a tungsten wire inside the lamp itself, and the current flows from negative to positive, so it goes around like this, and then the current itself is basically interacting with the lattice, the metal lattice in there, the tungsten filament, and it's causing it to glow at a certain temperature. So that's what's happening inside the actual metal tungsten filament. Outside of it, we need to actually know about how it works and everything. So what we're going to do is we're going to have a look at how it works, and to start off we're going to look at the electrical symbol for a tungsten filament lamp. So basically the electrical symbol is basically a circle with a cross in it, and that is a symbol for a filament lamp. So the IV characteristics of a filament lamp are as following. So what we have is we have the the current and the voltage, and what I'm going to do is I'm going to draw two different graphs for you, because from these graphs we're going to analyze both of them. So a filament lamp actually behaves in this sort of manner. So it does actually cross that 0 point like that, and then I'm going to draw exactly the same graph over here as well. So what you can see automatically is that it's not an ohmic conductor, so V and I are not proportional. It changes with temperature. So what we're going to say is V and I change with the temperature that you input, or what the filament lamp is at itself. So the first thing we're going to do is we're going to analyze this. So to work out the resistance at any point, what you do is you basically just pick a point and you do your delta Y over delta X. So for this point, it's going to be quite simply delta I divided by delta V. So to work out resistance, it is V over I. However, as you can see, the graph is actually inverted. So we're going to have to actually get the gradient of this. We're going to have to actually just do 1 over delta I over delta V. So whatever value for the gradient you get, you just do 1 over, and then you can work out the resistance. And you could do it for lots of different points. So I could do it over here as well. So you work out, draw a tangent, and then you can get the delta I over the delta V. So that's how you do that. So where is the highest resistance found? The highest resistance is actually found when the graph actually evens out. So over at this point, let's just do this point over here. So that's a higher resistance value, and this over here is a lower resistance value, only because the graph is actually inverted on itself. So that's how you get it. You just pick a point and you work out your resistance value from there by doing the delta I over delta V. What the key point about this graph I wanted to highlight is that in the winter there is a lower R value. So let's write this down. So in winter there is a lower R value resistance. So the filament cannot handle the surge in current. So it breaks, basically. And that's why in the winter you have so many bulbs actually breaking, because it just can't handle it. The resistance is not suited for it. So the surge in current, so the filament breaks. So on this graph then, because you've got a higher R, a higher resistance, what we're going to say is the higher resistance actually comes about in the winter over here. Winter goes over here because you've got a lower R, and then this is the summer. So as soon as you turn your bulb on in the winter, as soon as you come downstairs or go into a room with a bulb in the winter time, you've got a lower R value basically, and this current actually just fills the filament lamp, and then it's prone to actually break. So in the summer you don't get that, because the resistance is actually different in the summer. So that's why bulbs break in the winter and not in the summer.